parallel lines. Okay, so before we can continue to section 3.5, I gotta go back because you probably did this last year and I want you to remember how to do it. So we have different angles created when we have parallel lines in a transversal that cuts through those parallel lines. So to start out here, I'm going to draw in my parallel lines. It doesn't matter which lines you choose. I'm going to choose this one and this one. Okay, so these lines are parallel, meaning they're never going to intersect. Okay, so those two lines will never intersect. They are parallel to each other. Next, I'm going to draw in what's called a transversal. Okay, so a transversal is a line that cuts through both of those other lines. Okay, so this would be my transversal. Thank you. Okay, I'm going to label each of my angles created. So I have 8 different angles that are created when this happens. I have one right here. Second one right next to it. A third one below that. A fourth one next to that one. And then the other 4 are by the other parallel line. So I have 5, 6, 7, and 8. Okay, those are my 8 angles that are created. So we're going to look at what those different angles are called given parallel lines. Okay, so in my chart down here, I'll come back up to this, but in my chart down here, we have corresponding angles. Okay, the abbreviation for corresponding angles is CA. Corresponding angles, CA. Okay, if you have parallel lines, those angles are going to be congruent to each other, and that's what that symbol means. That symbol means congruent. They are the same. Okay, if you were to ever use this in a proof, you would say if parallel, that's the symbol for parallel, then our corresponding angles using our abbreviation, CA, are congruent. So if lines are parallel, then corresponding angles are congruent. This is where I'm going to go back up to the top here. An example of corresponding angles. Okay, corresponding angles lie on top of a line, okay, and are next to a transversal. So one pair of corresponding angles would be angle 2 and angle 6. Okay, so angle 2 and angle 6. What's another pair of corresponding angles? 1 and 5. Okay, so 1 and 5 are also corresponding angles. They lie on top of those parallel lines, and they're on the same side of the transversal. Now they could also lie in the bottom of the parallel lines. So 7 and 3 are also corresponding angles. Okay, 7 and 3 are also corresponding angles. They lie on the same side of that transversal and on the same side of the parallel line. Okay, next we have alternate interior angles. Our abbreviation is AIA, alternate interior angle. Okay, those angles, if your lines are parallel, are also congruent, so they are equal. Okay, they're going to be equal to each other. So to use that in the proof, just like the one above, we would say if parallel, then alternate interior angles, AIA, are congruent. Okay, an example of alternate interior angles in my picture above here. Okay, alternate meaning they have to go over the transversal. Okay, so over that line, and they have to be on the inside of your parallel lines. So one example of this would be angle 3 and angle 6. Okay, So my only interior angles here are 3, 4, 5, and 6. Okay, so since these are alternate interior, those are the only angles I can use. There is one other pair of alternate interior angles. Can you tell me what they are? 4 and 5. Good. All right. Next, we have alternate exterior angles. That abbreviation is AEA. Yes, I make my E a cursive E. I'm sorry. Those angles are also congruent if you have parallel lines. To use in a proof, we say if parallel, then AEA are congruent. An example of alternate exterior angles in our picture above. Okay, these ones have to lie in the exterior of your parallel lines. So outside the two sets. And then they also, again, have to skip over that transversal. So one example of this would be angle 1 and angle 8. Okay, you go over the top of that transversal, and it is in that exterior part. Okay, so angle 1 and angle 8. What's the other pair? 2 and 7. Okay, our last type of angle pair here are consecutive interior angles. Okay, that abbreviation is CIA, not Central Intelligence Agency. Okay, consecutive interior angles. Okay, those angles are supplementary. Okay, not congruent, they're supplementary. Supplementary meaning they add to 180. Okay, so add to 180 degrees. That's what supplementary means. So in a proof, again, we can write if parallel, because we have to have parallel lines for these to be true. Then our consecutive interior angles are supplementary. Okay, and an example of that in my lines above here. Consecutive interior angles, that's that interior word again, so they have to be in between your two sets of parallel lines. Consecutive meaning they lie on the same side of your transversal. Okay, so one pair of consecutive interior angles would be angle 4 and angle 6. Okay, they're on the same side of that transversal and they are between the two parallel lines. So we have angle 4 and angle 6. Okay, again, what's the other pair of consecutive interior angles? 3 and 5. Good job. Okay, questions? You know, some people are still writing, so I don't want to move too fast here. Okay, then what I want you to do is look at the next 4 questions. Okay, don't write anything down. So number 1 says, are corresponding angles always congruent? 2, are alternate interior angles always congruent? 3, alternate exteriors always congruent? And 4, consecutive interiors always supplementary? Talk to the people next to you. Do you think that is true or false? Not to me. All right, so I'm hearing a lot of yeses. I'm going to give you a scenario here. Okay, I have these 2 lines. I have a transversal that cuts through those 2 lines. I don't know. Lots of practice. If I label this angle 1 and this angle 2, those are still corresponding angles. But are they congruent to each other? No. The only way that they will be congruent is if your given lines are parallel. Okay, so your lines have to be parallel for those angles to be congruent. Okay, specifically when lines are parallel. So all of these are no. And again, this was my different scenario here. Questions? All right, so we're going to look at this next section here. We're going to find all of these angles in our picture. So we are given angle 11 is 62. Okay, so that's this angle right here. So I'm going to write 62 right there by 11. So I know that angle is 62 degrees. I can also write it over here right away. Okay, because I know that one is 62 degrees. I'm also given angle 14 is 38 degrees. Okay, so I'll write 38 degrees for angle 14. Now, I do have parallel lines in this picture. So these arrows within your line indicate that those lines are parallel to each other. Okay, so these two lines are parallel. So I can be on the lookout for these types of angles that are formed. So I can look for different congruent angles and different supplementary angles. So I'm going to do a couple with you here. Okay, so if my two lines right here are parallel, and I look at this one as my transversal, what would 11 and 4 be? It would be 62. Why? What type of angle is it? It is corresponding. So angle 4 is also 62 degrees. Now what about 14 and 6? It is 38. Again, same reasoning. Those are corresponding angles. Now I know we didn't talk about this angle, but do you remember what vertical angles are? Vertical angles are congruent. They're equal to each other. Which two angles are vertical angles? Whoa. 11 and 8. Okay, those are vertical angles. Those are also congruent to each other. So angle 8 would also be 62. Okay, then we can use that same information over here with 14. Okay, 14 and 9 are vertical angles. So 9, I'm going to run out of room here, is 38 degrees. Okay, what about 1 and 3? What's angle 1? 38. And 3? 62. All right, so now we kind of have to apply something else that's going on here to help us out. So, how can I figure out what angle 7 is? Yep.
Take the line going through here, and then each side roughly like at 180, right?
Yes.
And subtract 52.
Yes. So to find angle 7, angle 11 and 7, or 7 and 8, doesn't matter which one you use, have to add up to a straight line. A straight line is 180 degrees. So to find angle 7, I'll write this out. We're going to take 180 and subtract 62 from that. That's 118. So angle 7 right here will be 118 degrees. Okay, then what's angle 12? Okay, then I can use that same concept to find angle 10. Okay, so I can take 180 and subtract this angle 14 to get angle 10. And that is 142. Okay, meaning 13 is what?
142.
Look at that, we're almost done. Okay, we have 2 more angles. We have angle 2 and angle 5. Those ones are a little bit more confusing, but we can use that same concept we just did with angle 10 and 14 with that straight line with 1, 2, and 3. Okay, so angles 1, 2, and 3 create a straight line. So they all have to add up to 180. So to get angle 2, what can I do? Go ahead, Emily.
62 and 38, and then subtract that.
Yes. So you can add together angles 1 and 3 and subtract those from 180. So, or I could just do it this way. So to find angle 2, I could just take 180 and subtract those 2 angles that I know, which will be the same process. Okay, and angle 2 then is 80. Okay, then angle 5 has to be what? 80. Questions on how I got any of those angles? Is it kind of coming back to you? A little bit? Are we good? Can I flip it?
Yeah.
All right. So I got a couple problems on the back here. So this is where you're looking for those parallel lines, and you're looking to see, okay, are these 2 angles congruent? Are they supplementary? How could I set up an equation to solve for that variable? Okay, so in number 6, I have to find x and y. Okay, and I'm given that this angle is 114, and these 2 lines are parallel to each other. So I want to look for congruent angles here. Do you see any congruent angles with the numbers I'm given? Yes. Okay, this 114 and this y right here are congruent to each other. Okay, they are corresponding angles. So I know y has to be 114. Now that I know y is 114, oops, there we go. Okay, now that I know y is 114, I want to solve for x. Well, this angle with y and this angle with x here make a straight line. So what could I do to set up an equation to solve for x?
114.
Yeah? Okay, you can do that too. So I would take my angle here, x plus 12. I can add on this angle here, which is 114, and set it equal to 180. Okay, so I have x plus 12 plus 114 is equal to 180. Now, you can do this different ways. If you thought, well, I can take 180 and I can subtract 114 and then set that equal to x plus 12, that's right too. Okay, that's the same thing. So from here, I can combine 114 and 12. And then subtract that 126. To get x is 54. And those would be my 2 answers. Okay, questions on 6. Okay, then we're looking at 7. So again, I want to look for which two lines are parallel to each other. So I'm looking for these arrows here. So this top line, that one, and this bottom line are parallel to each other. Okay, I'm going to look to the right side of this figure. Okay, so I'm looking at this as my transversal line. And I'm going to cover up the rest of this here. What do I know about those two angles? They're congruent. Okay, why are they congruent? What type of angle pair are they? Not vertical. Look at the front. What type of angle pair are they? Alternate interior. I heard somebody say it. Okay, these are alternate interior angles. And I'll write that there so you can see that. Okay, they're on different sides of the transversal, so they're alternating, and they're both on the interior. So now that I know they're congruent, I can set those equal. So I can set 2x equal to 108. And then to get x by itself, I just have to divide both sides by 2. And again, x is 54. All right, I still have to find y. But this time I'm going to look at the left side. Okay, so this is my transversal now. And I'm looking at the left side. What type of angle pair? They're consecutive interior angles. Okay, on the front, what does it say about consecutive interior angles? Not congruent. They're supplementary. Okay, so that means you can add them together to be 180. So I can add together 5y plus 120 to get 180. Okay, I want y by itself, so I'm going to subtract 120. So I have 5y is equal to 60. Divide both sides by 5. And y is 12. Okay, questions? Do you understand the process I'm using here of how to find what those angle pairs are? Okay, you will be given that these are parallel lines, but you have to figure out what the angle pair is with those parallel lines. Okay, do you have any questions on how I did those two problems? Do you understand how I did them? Okay, because